Hello, pre-calculus students. Today we are going to talk about section 9.1, which is polar coordinates. So you will want something to write with, maybe some highlighters, your notes, a unit circle, and a calculator. Make sure that you are trying the examples as we go through them. Okay, so we have talked about the Cartesian coordinate plane before. That's just your regular XY axis. And today we're going to start talking about polar coordinates. So first of all, when you look at this axis, you're going to notice, wait, there's a bunch of circles. It doesn't go just left, right, up, and down. So we have circles. You might notice that you have all of these angle measures, and then you have all of these rings. So this fixed point here, which if we were thinking about a regular XY coordinate, we might think of as the point 0, 0. We're going to call this our pole or the origin. This is going to be our fixed point. Okay, the polar axis is the horizontal ray directed to the right of the pole. When I think about the polar coordinate system, I almost think about a globe and how you have all the latitudes and the longitudes, right, going around, and you kind of have the center of the Earth. If you were to take that and just kind of collapse it so it was 2D and you had like an aerial view, that's kind of what this would look like. Polar coordinates are going to have the form r theta. I write them in brackets so that I can distinguish them between a polar coordinate and an XY coordinates. Sometimes they'll also just be written in parentheses. The way you're going to know the difference is because that second number is an angle measure versus just a left-right direction or up-down direction. So the R is going to stand for radius. Theta is an angle measure. So instead of moving left, right, up, and down, the way we're going to move is we're going to move a radius and an angle measure. So example 1 asks you to plot and label the following points on the grid below, and then to find 3 additional representations of the point, and it gives you an interval from negative 2 pi to 2 pi. So there are a couple of different ways to go about this. You can either start with the radius and then think about the angle, or start with the angle and then think about the radius. Okay, there's not really a wrong way to approach it. Okay, so this 3, 5 pi over 6. So the 3 tells me I have a radius of 3. So I would have to go out 3 rings, and then I'd have to go to an angle of 5 pi over 6. So a positive radius you could think of as going to the right 1, 2, 3, and then I have to rotate in a counterclockwise direction 5 pi over 6. So here is my point A. So here's my point A. Okay, for point B, it's 2, 3 pi over 4. So the 2 is again going to mean a radius going out 2, and then I'm going to rotate counterclockwise 3 pi over 4. Now I know that it kind of looks like a unit circle. This is in radians versus degrees. It could be in either, but we don't see a 3 pi over 4. But we do know it would be along this kind of right in the middle between the 2 pi over 3 and the 5 pi over 6. And the radius was 2. So right here is my point B. It's kind of hard to see a little bit. Okay, now point C has a negative radius and a negative angle. So the negative radius, probably most of you are like, okay, I have to go to the left 3. So 1, 2, 3. But now my rotation is negative 7 pi over 6. So that means I have to go clockwise 7 pi over 6. So from here, from this 1, 2, 3, from this negative 3, I have to rotate 7 pi over 6 now clockwise instead of counterclockwise. So that's where it can sometimes be confusing. Now, if you think about a unit circle, 7 pi over 6, if I went counterclockwise, is a rotation right here. So I went half the circle and then I went one more space, right? I want another sixth. So if it's negative 7 pi over 6, then what that means is, so I go to the left 3, and then I have to rotate clockwise 7 pi over 6, which is the half circle, and then another sixth. So that would put me right here for my C. For some people, it's hard to see it that way, especially once you start getting into those negative rotations. Another way to do all of these is to first start with the angle and then apply the radius. So for example, for part B, the 2, 3 pi over 4, I could go to the 3 pi over 4 angle, the line, and then my radius is 2. So go towards the 3 pi over 4 in a positive direction. If it had been a negative 2, I would have gone backwards 2, away from the angle. And we could use that thinking here. We could have started with a rotation of negative 7 pi over 6, which means start here and then rotate 7 pi over 6 clockwise, which would put me here. But it's a negative radius, so instead of going toward my angle, I'm going to go away from my angle, which is going to put me right here. So 2 ways to see that. Okay, this one has a radius of nothing, so it stays at the origin. While if the radius is nothing, doesn't matter what this angle is, no matter what, my point is going to be at the origin. So my D is just at the origin. All right, and then the last one, 3 halves, which would be a radius of 1.5, and then an angle of 3 pi over 2. Again, if you can either go out a radius of 1.5 and then do the rotation to 3 pi over 2, or you could go to the angle 3 pi over 2 and then go towards it 1.5 and then put your point there. So that would be my point E. Now remember that each angle, we talked about this in chapter 5, has multiple ways it could be represented because we have coterminal angles. And so that means every polar coordinate can be represented an infinite number of ways. So for point A, it was named 3, 5 pi over 6, but what I could do is I could keep adding multiples of 2 pi and subtracting multiples of 2 pi and get more and more representations of that point. Now the directions here said specifically to give 3 additional representations on the interval from negative 2 pi to 2 pi, and that's what we're going to do next. Okay, so I'm going to kind of use the unit circle. Imagine, now this we know had a radius of 3. So imagine this had a radius of 3. Let's say this is 3 right here. And here is my 5 pi over 6. What I want to do is I want to think of 3 other ways that I can get to 5 pi over 6 and staying within the boundaries of being between negative 2 pi and 2 pi. So when I went this way here, that's my 5 pi over 6. So now, what if I were to start here and go clockwise instead of counterclockwise? What would that rotation be? We kind of just talked about that rotation, how it's like half and then another 6, that's 7 pi over 6. But because I'm going clockwise, it's negative 7 pi over 6. So another way that I could get to this spot here is I could use the angle negative 7 pi over 6. And the radius would still be 3. So another way that I could name this point would be 3 negative 7 pi over 6. You can't see that. Okay, that would be another way that I could name that point. All right, now another way that I could get to that same point is if I were to consider having a negative radius. So a negative radius would mean if, let's say I had my angle over here, a negative radius would shoot it to the other side. So another way that I could, another way that I could get to that same spot, instead of using this angle over here, is I could use the angle directly across from it. So I could use this angle here, this 11 pi over 6. If I say that's my angle, I could use a radius of negative 3, and it would bring me over here. Okay, so another way that I could name this point is I could say negative 3 and then 11 pi over 6. And that would be another way. So it's that I'm going all the way around, like here's my 11 pi over 6 here, but a negative radius means over here. Okay, that's if you kind of think about the angle part first. If you think about the radius first, -3 would be over here, and I want to get to here. And if I want a positive rotation, I would have to start here and I'd have to go all the way around except for a 6, which is an equivalent rotation of 11 pi over 6. So rather than doing that, I can just know, okay, it's going to be directly across here. So I could use 11 pi over 6. Now, another way that I could get to this 11 pi over 6 would be, instead of going counterclockwise, what if I went clockwise? That rotation is negative pi over 6. Okay, that puts me here, but I want my point to end up over here. Remember, point A was over here. And so to get me to the other side, I would have to have a negative radius. For these, to me, it helps to think of the angle and then the radius, but there's more than one way to do it. So that's how we're always going to get our 4 or our 3 additional. So whenever they say anything about like name all the ways it can be named between -2 pi and 2 pi, you're always going to have 2 associated with a positive angle, or 2 positive radii, and you're going to have 2 negative radii. And within each of those, you'll have 1 positive angle, 1 negative angle. And that's what we had here. We had 2 positive radii, and then we had a negative and a positive angle. Here we had 2 negative radii, and we had a positive and negative angle. Now, if it just said, give me 3, the directions like on homework might say something like, just what are 3 different ways that we could name this point? You could just keep adding multiples of 2 pi or 360 degrees, depending on what the directions say. Like sometimes it says degrees, sometimes it says radians. So make sure that you pay attention to that also. Okay, so that takes care of the first one. If I were you, what I would do is I would now try the remaining ones on your own and see what you come up with. And when you do it, you know that you should always have a positive radius. Like you should have all the common, a positive, you should have a positive and negative. You should have a negative positive and a negative negative. Okay, for all of these, if it's falling on that interval from -2 pi to 2 pi. So see, what do you start with? So here we start with the positive, okay, because I'm right here. Okay, now think about, well, how could I get it to still have a positive radius, but now think about what would the negative rotation be? Okay, and then think, all right, well, if I had a negative radius, so if I were to start like over on the other side, what would my rotations have to be? And so, like I said, I would pause if I were you and first do them. Okay, so our next point was this 3 pi over 4, and imagine this was a radius of 2. Okay, so imagine our radius is 2. So we had started with, not on the screen, 2 and 3 pi over 4. So remember I said you're going to have 2 positive radii, 2 negative radii, 1 positive angle, 1 negative angle. Okay, so what would the negative equivalent be? So if this is 3 pi over 4 here, then another way to get to that same angle but with a negative rotation would be to start here and go clockwise. So what's that angle? I went half and then I went up 1/4 pi. So normally when I go half and 1/4 pi, it lands me at 5 pi over 4. So if I went -5 pi over 4 and had a radius of 2, that would put me right here. Notice that the relationship between the 3 pi over 4 and the -5 pi over 4, they're always like vertical from each other. That was the case on the last one also, because our one angle was 5 pi over 6, and then the negative angle was -7 pi over 6. And then we had 11 pi over 6, and we had negative pi over 6. It's always going to be that relationship. So that's something also to hold on to. All right. So now these had a positive radius. Now imagine a negative radius. So that means we would start with the angle directly across and then have a negative radius to shoot us over. Okay, so directly across from 3 pi over 4 is 7 pi over 4. So my angle could be 7 pi over 4. And then because 7 pi over 4 is over here, but my point was over here, I would need a negative radius to move me over. So this would be a -2. Okay, 7 pi over 4 is this rotation here. So then for my other angle, for my negative angle, I would use this rotation. Okay, that rotation is equivalent to just doing -pi over 4. So if my angle was -pi over 4, and that would bring me down here, but my point was in the second quadrant over here, so I would need a negative radius to get me over there. Okay, so then that gives me my points for part B. So this would be 2 negative 5 pi over 4, and then I had negative 2 negative pi over 4, and then negative 2 7 pi over 4. Okay, so then let's take a look at part C. So for part C, we were over here, and this was a rotation of negative 7 pi over 6, right? So that was a rotation of, negative 7 pi over 6, but then with a radius of negative 3. So that was that I had gone negative 7 pi over 6 and then went back negative 3. My marker is lousy. Okay, so it was negative 7 pi over 6. So this point here that I was given was negative 7 pi over 6, and it was a radius of negative 3. So that took me to here, and then I came across to here with a negative radius. So then I'm going to have another negative radius. Now, what if I had a positive angle? So instead of going backwards, or what could I have done instead? I could have gone and done what? I could have gone positive, right? So I could have done negative 3 and 11 pi over 6. No, wait, that's not right. That would be positive 3. That's this one over here. Oh, goodness, I've lost it. All right, what I could have done, no, I could do that. That works. 3, and I could do 11 pi over 6. I'm losing it, guys, sorry. Okay, so if I used 11 pi over 6, that would be a positive 3. Then this was over here. I should have had this one over here. Sorry. When I drew it, I should have drawn it. Sorry. Okay. This should have been over here. All right, so then the negative that would go with this would be that I go backwards, right? So my negative angle would be negative pi over 6, and my radius would be 3 because I'm going toward that angle, so 3. Okay, this was the one I was given where I went negative 7 pi over 6 and then back over here with a negative 3. So then I want to think about, instead of going negative 7 pi over 6, well, what could I have done instead of going backwards? If I had gone positive, it would just have been an angle of 5 pi over 6. So I could have done 5 pi over 6, positive, and then the negative 3, right? So 5 pi over 6, but the negative would get me over here. It is kind of a lot at first to kind of get the hang of how it works with the negatives because you're rotating and you have a radius. And then especially when it's negative, it can just get to be a lot. Now with this, it's at the origin, right? So I know all the radii are going to be 0. So that's a little bit different. Technically, you could really have any angle in that interval, and that would make it work. Now, if you wanted to practice the idea of, okay, well, how can I get all the different possibilities? Like, okay, well, here's negative pi over 4. So instead of going negative pi over 4, I could have gone a positive 7 pi over 4. So if you want to practice getting all the things that will kind of give you that same rotation, I also could have done 3 pi over 4 directly across, or I could have gone the other rotation and done negative 5 pi over 4. All right, and then for our last one, so that's this guy right here, instead of doing 3 pi over 2, I could have done, instead of doing this, I could have done negative pi over 2 for my angle, and then kept the same radius, right, positive, it's going toward that point. Or I could have done a rotation of pi over 2, positive pi over 2, but then if I'm over here to get to the other side, I'd have to make this negative 3 halves. And instead of going positive 3 pi over 2, I could have gone negative 3 pi over 2. And then I'm on the wrong side, so I'd have to have a negative radius to get to the other side. Now, this rule here, so in general, multiple representations of the r theta can be obtained by using the following, where k is any integer. This is the idea that if it's positive, I could just add multiples of 2 pi. If it's negative, it's a little bit different. I don't really bother memorizing that. I just kind of look at it and figure it out from the unit circle. Okay, so then next, an equation expressed in terms of polar coordinates is called a polar equation. A polar graph is the set of all points whose coordinates r, theta satisfy a given polar equation. Okay, we're going to today look at a couple of very basic polar equations, and then later in the chapter we'll look at some more complicated ones. The graphs of these actually get really interesting. Okay, so r equals 3. So r equals 3 means, okay, for every single value, any point where the radius is 3 is part of this graph. So anywhere where the radius is 3, so if I say this is a scale of 1, anywhere where the radius is 3 would be all along here, over here, over here, over here, over here. So all of this whole circle with the 3 would be r equals 3. Okay, not just like on the positive side, but anywhere. And then the next one, theta equals 3 pi over 4. So any point along here that could have an angle of 3 pi over 4. Now again, 3 pi over 4 isn't on this, but you know it's between. Now the thing that people will sometimes make a mistake on with this is they'll say, oh, 3 pi over 4 is over here in the second quadrant, and they'll just draw this ray in. It does have to have the arrow on it, but remember, that's only if you had a positive radius. Okay, so any point for which the angle is 3 pi over 4, well, you could also have a negative radius, which would shoot it over here. Okay, so just make sure that it goes through, it's a line through, not just a ray, and it does have arrows on it. All right, the last thing we're going to talk about is using the distance formula in the polar plane. So, it's kind of difficult to read on here, but I have 2 points. I have the first point is r1, theta 1, and then the second point here, P2, is, r2, theta 2. And I want to find the distance between those 2 points. And I know it's difficult to see that on that grid. Now, so the radius is r1 here, r2 here. And can you see these angles in here? There's a theta 1 and a theta 2. I'm going to resketch this over here so we can see what's going on a little bit better. Okay, so I have some point, P1, and I've got another point over here, R2, theta 2. I want to find the distance between them. Now for this point, I'm going to draw this in. Here's my theta 1, and I'm going to draw this radius in. This is, that whole angle there is theta 2, and I want to find this distance. Well, do you see how you have, oops, did not draw that very well. You see I have a triangle there? All right, so we learned lots of stuff about triangles in chapter 5. So with this triangle, I know that here's my radius 1, like this length here is r1. I know this length here is r2. And this is what I'm looking for here. So what can I use to find the length in a triangle? So we had sine, cosine, tangent ratios. We had law of sines. We had law of cosines. Okay, for law of sines and law of cosines, they usually involve an angle. Do I know any angles? Well, if I know this whole angle is theta 2 and this little angle is theta 1, then that means that this angle here is theta 2 minus theta 1. Right, so if the whole thing is theta 2 and then that little part is theta 1, then theta 2 minus theta 1. So I have an angle, but I don't have the side across, which means I can't use law of sines. That means we have to use our friend, the law of cosines. So the side I'm trying to find is my C. Remember the side and then the angle across. So my angle is the theta 2 minus theta 1. So this is r sub 1 squared plus r sub 2 squared minus 2 r1, r2 cosine theta 2 minus theta 1. Now, when we're trying to get a distance formula, we try to get the variable over here by itself. So my distance is the square root of that. No simplifying we can do. Okay, so that's our distance formula. Example 3, I'm actually going to get rid of this and I'm going to change it because the homework is a little different. I'm going to give you one similar to in the homework. So if I were to give you, and in the book, they use parentheses. I know I used brackets for my polar coordinates. I think it's easier to keep them apart, but this is what it would look like in the book. It would say, find the distance between these points. Okay, so then I could say this is R1, this is theta 1, this is R2, this is theta 2. And I would just substitute into that formula. Now, when you go to substitute into the formula, careful with those angles. Because your calculator is probably in degrees, because everything pretty much we've been doing has been in degrees, or like you didn't use a calculator at all sometimes, but for the most part, degrees. And these angles are in radians. So you've got two choices. You can put your calculator in radians, or you could think about, okay, well, this is just 135 degrees. This is just 30 degrees, and you could just convert those into degrees. That might just be the easiest thing to do if you want to put it into your calculator all in one step. And you can do that. You can just type in the square root of 1 squared plus 5 squared minus 2 times 1 times 5 times the cosine of that would be 105. Just put it all in at once. You should get that it's about 5.3 units. Okay, so that's the basics of polar coordinates. This chapter, we're going to talk about graphing. We're going to talk about converting between rectangular and polar. We're going to make a lot of connections between polar coordinates and what we did in chapter 8 with vectors. That's it for 891.